Okay guys, welcome to this video looking at Core 1 basic algebra questions, mainly Surds. Okay, so we're looking at AS Pure Maths here in this video, so it's appropriate for Year 12 and Year 13 students, and also GCSE further math students and GCSE higher tier as well. But this is aimed at A-level pure maths, okay? So please be mindful of how the questions are worded and presented and how many marks they're worth, okay? Because at GCSE, the marks would be worth accordingly, depending on the level that you're looking at. Okay, as ever guys, please feel free to pause the video, try and attempt all these questions, and then come back and press play when you're ready. This is question number 1, part A. Simplify root 5 plus 2 times root 5 minus 2. Well, expanding brackets, root 5 times root 5 is root 25, which simplifies to 5. Root 5 times minus 2 is minus 2 root 5. Positive 2 times root 5 is plus 2 root 5. And then positive 2 times negative 2 gives me negative 4. Okay, because a positive times a negative for that one. Okay, so collecting like terms, they're going to cancel. 5 take away 4 is equal to 1. Okay, so this one's like a special case here. This one's expanding brackets involving the difference of two squares. Okay. Part B, express root 8 plus root 18 in the form n root 2, where n is an integer. So it's simplifying surds. So root 8 can be expressed as or written as the square root of 4 times the square root of 2. Okay, and the reason why I've chose this is I'm looking for the biggest square number factor that goes into 8. So it's relying to have knowledge on our square numbers. The square root of 4 is 2. 2 times root 2 is 2 root 2, guys, for that one. Okay, and then the square root of 18 is the square root of 9 times the square root of 2. Okay, so 9 is the biggest square number factor that goes into 18. But the clue here is in the question it said in the form n root 2. So you have something times root 2. Okay, so to work out the missing number, what you could do here is do 8 divided by 2 to work out 4, and then 18 divided by 2 to get to 9. The square root of 9 is 3, so we're going to have 3 root 2, guys. 3 times root 2 is written as 3 root 2. Adding these together, 3 root 2 plus 2 root 2 is 5 root 2, guys. Okay, so that's how I simplify my surd for that one. Okay, so let's just delete this so we have a bit more space. Okay, feel free to obviously rewind, okay, as and when you need to. Okay, but I'm just deleting it so I have space for other questions. Okay, question number 4, part A. Express these double bracket surd in the form p plus root 5, where p and q are integers. So integers just mean whole numbers. So expanding brackets with surds, 4 root 5 times root 5. Well, root 5 times root 5 is going to be 5. Times that by 4, I'm going to get 20. So 20, and I've got 4 root 5 times positive 3, which is going to be plus 12 root 5. Okay, the negative 1 times root 5 is going to be negative root 5, or negative 1 lot of root 5. Okay, that's also fine. And the negative 1 times positive 3 is going to be negative 3, because a negative times a positive goes to a negative. 20 take away 3 is 17. 17 plus 11 root 5. Okay, for that one. Part B, okay, show that root 75 minus root 27 all over root 3 is an integer and find its value. Okay, so I've got to rationalize this. So I'm going to multiply top and bottom by root 3. Okay, so I am going to get some big numbers here, but hopefully if you bear with me, okay, on this. So we multiply top and bottom of this fraction by root 3. And the reason for that is we are rationalizing the denominator. So we're getting rid of the surd on the bottom part of my fraction. Okay, right guys, so I'm going to have root 75 times root 3 is going to be root 150. Okay, and then root 27 times root 3 is going to be root 81, which simplifies to 9, okay, because the square root of 81 gives us a whole number. Root 3 times root 3 just goes to 3. So I'm going to simplify this surd here. I've got something take away 9 all over 3, okay, if that makes sense so far. So root 150 is root 25 times root 6, okay. So we are going to have 5 lots of root 6 here. Oh, sorry guys, I think I've made a mistake here. It's a square root of 225, not 150. I apologise. Okay. So that actually makes the sum a bit easier now. 150, sorry, is double 75 and not triple. The square root of 225 is going to be 15. Okay, because 225 is a square number. 15 take away 9 is 6. 6 divided by 3, I get the answer of 2. So I get the whole number 2. Okay, integer just means whole number, okay, including 0 and negative numbers. Okay, question number 3, guys. So express root 5 plus 3 all over root 5 minus 2 in the form p root 5 plus q, where p and q are integers. So again, rationalizing the denominator. So multiply top and bottom by its conjugate. Okay, so I'm going to have root 5 plus 3 over root 5 minus 2. Okay, I'm going to multiply top and bottom of this fraction by 1, i.e. root 5 plus 2 over root 5 plus 2. Okay, so I'm timesing by its conjugate. All that just means is a fancy way of saying, well, whatever the sign is here, it becomes a plus on the top and bottom, okay? So it's the same number, but then I just change the sign of that. And the reason for that is we get the difference of 2 squares on our denominator, okay, which gives us a whole number answer. Okay, so on the bottom, we're going to have 5 take away 4, which is going to be just 1, okay? So your answer is going to be all over 1. On the top, I'm going to have root 5 times root 5 is root 25, which simplifies to 5. Okay, plus 2 root 5 plus 3 root 5, so we're going to have plus 5 root 5, and you simplify that, and then 3 times 2 is going to be 6. Okay, so collecting our like terms, okay, dividing by 1 doesn't change our answer, so let's just get rid of that division by 1. Okay, 5 plus 6 is 11, so we're going to have 5 root 5 plus 11. Okay, so it's just expanding brackets with surds. Okay, I apologize if I jump like a step here, but it's just expanding a double bracket with surds and collecting your like terms. Okay, on the bottom, I have the difference of 2 squares, so the middle terms will cancel, so I'm left with just root 5 times root 5 is root 25, which simplifies to 5, and then minus 2 times 2 is going to be 4. So I'm going to have 5 take away 4, which gives me 1. Okay, and on the top I'm going to have root 5 times root 5, which is 5, plus 2 root 5, plus 3 root 5, which gives me that 5 root 5, and then 3 times 2 is 6, which is where that 6 has come from. Okay, part B, part I, guys, express root 45 in the form n root 5. Okay, so it's simplifying surds. Okay, again, it's finding the highest number square factor that goes into it. A little clue here is I've got a root 5. So it's going to be the square root of 9 times the square root of 5. The square root of 9 is going to be 3, so I'm going to have 3 lots of root 5. Okay, for that question, so I'm going to have 3 root 5. For that question. Part I, solving this equation. Okay, so let's just delete this part. Now we've got a bit more space. Okay, so we've got x root 20 equals 7 root 5 minus root 45. Well, I can just replace that first of all with this, 3 root 5. So I have x root 20 is equal to 7 root 5, take away 3 root 5, which is going to be equal to 4 root 5. And then we're going to divide both sides by root 20 to get x on its own. So dividing both sides by root 20, we're going to have 4 root 5 all over root 20. Now I could rationalise this, however, I recognise that I can simplify root 20 first. So root 20 is the square root of 4 times the square root of 5. So root 20 is actually 2 root 5. Okay, which makes the sum much easier to deal with. Okay, so it's where possible you want to simplify your surds. Okay, so I get 2 root 5 on the bottom of my fraction. Okay, so then now that becomes 4 root 5 divided by 2 root 5, which just simplifies to 2. So x is equal to 2. Okay, because you have 4 root 5 divided by 2 root 5. Well, the root 5s just cancel. I get 4 divided by 2, which is just the number 2. Okay. Question 2, part A. So express root 63 over 3 plus 14 over root 7 in the form n root 7, where n is an integer. So let's just rationalise this. Okay, 14 over root 7, multiply top and bottom by root 7. Okay, to get rid of that denominator on my surd. Okay. Root 7. So 14 lots of root 7, or 14 times root 7 is written as 14 root 7. And then root 7 times root 7 is root 49, which simplifies to just 7. 14 divided by 7 is just 2, guys. So I'm going to have 2 root 7 for that part. Okay. So the square root of 63 divided by 3 . Well, I can simplify root 63, okay, as root 9 times root 7. So root 63 is root 9 times root 7. The square root of 9, we should know that simplifies to 3, or the number 3. So we're going to have 3 lots of root 7. Okay, adding our answers together, because I've got a common surd now. 3 root 7 plus 2 root 7 goes to 5 root 7. Okay, so hopefully that makes sense. Part B, guys, express this surd, okay, in the form p root 7 plus q, where p and q are integers, so p and q are whole numbers and or 0 or negative numbers. So multiply by its conjugate, so times by top and bottom by root 7 plus 2 over root 7 plus 2, okay? and that will get rid of the denominator on the fraction. Okay, we always multiply by its conjugate. Okay, so all that just means is you change the sign, okay, to root 7 plus 2 over root 7 plus 2. Okay. Okay, so the denominator is going to simplify to root 7 times root 7 is going to be 7. Okay, minus 2 times positive 2 is going to be negative 4. So 7 take away 4. So 3 is going to be on the denominator of my fraction. On the top, I'm going to have root 7 times root 7, which is going to be 7. Root 7 times positive 2 is going to be positive 2 root 7. Plus 1 times root 7 is going to be positive root 7. And then positive 1 times positive 2 is just positive 2. Or plus 2. Okay. So collecting my like terms, simplifying everything, I'm going to have 9 plus 3 root 7 all over 3. Okay, I can divide everything through by 3. So I'm going to have 3 plus root 7, which I can write it in the form of root 7 plus 3. Okay, because I'm looking back at the question, it wants it in the form p root 7 plus q. So it's going to be root 7 plus 3. Okay, and if you're interested, p would be equal to 1 and q would be equal to 3, guys. Okay, for that. Okay. Right guys, that's the end of today's video on Core 1 basic algebra questions for mainly Surds. Okay, so I sincerely hope you found it useful. I hope you found information about Surds informative, useful and helpful. Okay, please feel free to ask me any questions in the comment section. Hopefully you were able to take some notes from today's video, okay, if this was new to you. Okay, but do let me know how you get on, guys, and how you're getting on with your studies this term. Okay, but that's it for me today, guys. Thank you so much for watching. Take care, stay safe, stay healthy, and I will see you in the next video. Okay, bye for now.